Hey guys, welcome back to AlgoYogi. We are doing binary search, and our next problem in the list is minimize the maximum difference of pairs. So let's go to LeetCode and give it a read. So you are given a zero indexed integer array nums and an integer p. Find p pairs of indices of nums such that the maximum difference amongst all the pairs is minimized. Also ensure no index appears more than once amongst the pairs. All right, so note that for a pair of element at the index I and j, the difference of this pair is basically the absolute value. Even if the difference is basically from the smaller number minus the bigger number, that means the bigger number minus, no, the smaller number minus bigger number, the difference will be in negative, but like we're taking the absolute value. Okay, so all right, so let's return the minimum maximum difference among all p pairs. Okay, so we define the maximum of an empty set to be 0. Okay, nums, basically this is a list of numbers. We need to basically make a lot of pairs out of these. Now we need to find p number of pairs in such that the difference between these pairs. So basically, if we make pairs of, let's say, 10 and 1, 1 and 2, 2 and 1, 1 and 3, so the difference will be between those numbers will be basically 10 and 1 will be 9, 2 and 7 will be 5, 7 and 1 will be 6. We have to minimize the difference. And then we have, with that minimum difference, we have to find basically p number of pairs. Sounds complicated, but trust me, it is not. When we are gonna go through it, like on pen and paper, it will really sound like really easy. So here the example is 1, and that is because it can tell you if you see 1 and 1, the difference is 0. Difference is 0. And we need to find 2 pairs, so that would be the minimum difference. But you cannot find any other 2 numbers that where the difference is also 0. Otherwise, our answer would be 0. So then I guess you can take either 2 and 3. That's what you will take. And here the difference would be basically, or you can take 1 and 2. So one index cannot appear like again and again. Basically, these two cannot be similar. I and j cannot be similar. That's what they said right here. They have to be different elements, but I guess you could utilize basically 1 and 1 and 1 and 2. All right. So here, first and fourth they have given is first is 1, fourth is 1. So difference is 0. They have said 0 is over here, and then they have 2 is basically 2 is over here, and then they have fifth is basically 3. The difference is 1, so our answer is 1. Okay, let's go over it. Let's go over it here. Now we are given, this is basically our number list. This is the number of pairs that we need to make, and we need to minimize the difference. Minimize the difference, but minimize the maximum difference basically. Okay, the problem statements is like a little confusing. It sounds so complicated. All right, so how are we actually going to make pairs here? So if you go by the brute force approach, how about we create all the pairs in this list? So I can create basically, I'll basically using big of n square time complexity, I can make all the pairs from these elements. So 10 pair would be basically, let's say 1, and then 10 paired with 2, 10 paired with 7, and 10 paired with 1, and blah 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 blah. There will be so many pairs, and then out of these pairs I want to find the pairs which have the minimum difference. So what were those pairs? I think 1 and 1 was one pair, then 1 and 1 was one pair, and then 2 and 3 are another pair. Okay, so if you see over here, what is the difference between these two, the elements between these two pairs? This one gives us a difference of 0 and this one gives us a difference of 1. What is the maximum difference out of these two? Because we just needed two pairs, right, mentioned over here, so we'll return the answer 1. Okay, now you see, now you understand the problem statements. So let's go about how should we do it. Okay, how should we do it? If you see over here, I guess what would make most sense to find the reference, minimum difference, would be by sorting these elements. Okay, let's sort these elements first. So we sort these elements, I would get 1, 1, 2, 3, 7 and 10 after sorting these elements. Now tell me, where would the minimum difference between pairs would lie? Right here. So this is one pair, this is another pair, and this is another pair. All right, or even if they didn't exist, this pair didn't exist, then my pair would be basically either this, or I think that's it, or maybe 10 and 1, right? But why would you choose non-neighboring elements as pair? Because they will absolutely have like more value as difference. Okay, so we'll choose neighboring elements as for pairing up. Okay, so here we will choose these two, and then here we will choose these two, and then the difference is 0, and then the difference here is 1, and we return, basically we have two pairs satisfying our P, and then we return 1. Okay, so we are going to first sort the element and then go over this element to find basically two pairs, and then whatever difference we have, then we basically return that difference, maximum difference. So how about we do it basically in a way that's more optimal. So in this case, what we are really doing is first we are sorting it. Sorting will take big of log n log n complexity, and after sorting, what we are doing is we are going over maybe first we need to find out like where is our range, what our range will be for those differences, and then within that range we want to go from the lowest to the maximum difference range, and wherever our condition for P satisfy, that's where we will return our answer. So let's say first we have this sorted list. Then what we will do is, so 1, 1, 2, 3, 7 and 10. Now we have this sorted list. What we want to do is, let's see what will be our range of difference values. What will be that? Don't you think that will be basically what will be the maximum difference out of these pairs, whatever pair we can make in this sorted array or whatever? So I think that will be 10 minus 1, that is 9, and basically the first two element, or like the minimum elements over here, that would basically be, I guess, 0. In most cases that would be 0. So it will start at 0, and then even if it doesn't have 0, we will find out, because we need to find two pairs at least. So but for safety we can just assume like 0 could be the minimum difference between any given number of values, because some values would be equal, so that makes the difference 0, and then this will be my range. Okay, this will be my range. So what I want to do is, I will go, and let's say its length is m, this range length is m. So what I'll do is, I'll go from beginning of this range till end, trying one difference at a time, and then checking if I can find basically p number of pairs that have a difference less than or equal to basically that difference, if we choose that as maximum difference. Okay, so let's say if I choose 0, then what I'll do is I'll go over this list and then I'll try to find the pair that will basically that will happen in big of n time complexity. That is because we will use a while loop starting at the first index and then check if going until the second last index, and then check if this pair that we are making, these two neighboring elements, is the difference here is lesser than or equals to basically the difference that I'm choosing, which is 0. In this case it is. So 1, I have just found one pair. Then I'll increment my pointer basically by 2 because these two elements I have used. So I'll basically try at this point. So I'll try compare these two, and I see that these two do not have a difference that is of 0. So I'll try another element basically, then I'll increment by 1. So I'll try basically these two. Remember why I'm trying, because I'm not utilizing this, so I need to try the next element. This couldn't make a pair, so let's say if these two could make a pair that have a difference which is less than or equal to 0. These two don't, and these two also don't, so it will return false. That means we cannot choose this value as our difference, so we'll pick the next value, which would be basically 1. So let's try 1. We will try 1 here. This will satisfy, and these two will satisfy. Once these two satisfy, then that means we don't have to keep checking. We just found two pairs because this is lesser than lesser than or equal to that number of pairs we are creating. So it will return, and then this will be our answer. So if you see over here, whatever we did, we have this linear range and we are linearly searching. We have this range from 0 to 9, and then we are searching linearly. If we can find a number from here to basically until 9 that will satisfy our condition to basically find p number of pairs, if we choose that as basically minimum difference, or sorry, maximum difference, what I mean to say. Although we are minimizing the difference, but we are choosing the maximum difference. So how about, so that would be the brute force approach, and time complexity would be m into n, because for each m from this list, we are basically from this list we are again going in my linearly, we're doing a linear search to basically find these neighboring pairs, to count the number of pairs that we could create. All right, so this will be of time complexity m into n, right? Can we do better? Yes, we can. That's why we are here. That's why we are this problem is in binary search, and this difference that you see over here, this range, how about instead of finding something linearly, the maximum difference linearly, how about we choose we use binary search, right? How about we use binary search? So let's do that. Okay, how do we do it? We have this range that starts at 0, 1 and blah blah blah, and it goes up to basically 9 in this particular example, but usually it would be this value comes from max would be here and minimum would be here. So basically you can just, even in a sorted array, you can say if you have nums -1, basically last element minus nums 0 element, okay, the first element. I think that will give you this, and 0 remains 0. So how about I find out the middle element and I try that to be my maximum difference, or minimum difference, or minimum maximum difference whatsoever. Although I'm trying to minimize this maximum difference among these pairs. Okay, understand the problem. So what I'll do is this time I'll get 4, right? M is basically, you know how to calculate m. That's left pointer, right pointer, which will be over here. This is my right pointer, this is my left pointer, 0 and 9, and I'll get 4 as my maximum difference to try. So what I'll do is if I'm choosing this as maximum difference, what I'll do is now I will have this helper function which will take this medium value as a maximum difference and go to check linearly in this sorted array, can I find two pairs that have a difference that is less than or equal to 4. Yes, they do. These two, and even these three, we found 3. Yes, so if this count that it's gonna return us is greater than equal to p, that means this is a valid answer. If this is a valid answer, should we return that? No, because we need to find a minimum value. We have done that in the previous problem. This follows the same pattern, right? So what I'll do is I will reassign my right pointer to mid -1, so which will be 3, right? And then 2 in between. So I'm gonna still try these values. So I'll find out the mid here, which will be again 1. I'll try 1 will qualify, and then what I'll do is I'll assign this to my answer result, but again I'll move my right pointer here. So now if you see, they both become same. We can still try this, but this will fail, and then our result will be basically still be 1, and that's what we will return. So I guess at this point we know what to do, and let's write down the code. And this will bring down the time complexity to big of if this is m, so n times log m. And why this is better than m into n is because this m could be really large because of this difference that we can have. It could be really large, and that's what basically makes this problem accepted using the binary search. So if we switch, and I think before that I want to show you guys that what I mean that value could be really large. So if you see over here these values, this value could be 10 to the power 9, which is way bigger than n. N is the size of this, and n we are choosing is the size of the integer array nums, and this value that you choose could go up to basically 10 to the power 9, which is way bigger than 10 to the power 5. Okay, so this could pass as like n square or something, but this wouldn't pass as n into m because this is really large. That's why we need that log m. Okay, so I'm gonna just focus over here and let's start writing the code. And I think I'm gonna discuss it in detail while writing the code so that we develop our understanding, comprehension, that what we are doing, why we are doing. So first thing first, we're gonna sort the array. So let's sort the array. So nums dot sort. I'm creating some gap here for that helper function to basically count number of pairs with that difference. We're choosing some maximum or minimum difference, whatever you guys want to call it. We understand the problem, and the wording is a little confusing, of course. Okay, so let's sort it. Now let's choose our left, and I'm not writing the brute force solution. You can write it and then write this one. I'm just choosing to write the main solution. So left would be basically 0, and then right would be basically nums -1 minus nums first element. So this will give us the maximum difference because this is the largest element after sorting, which exists at the end of the array, and this is the smallest element which exists in the beginning of the array. So that will give us this maximum difference. For result, let's choose maximum difference as I guess this itself. This will give the maximum difference, so that we will at least find that number of that many pairs under this difference, definitely, because this is the largest maximum difference that exists on one pair in the list that's given to us. Rest every other pair could fall under their difference would be lesser than this. So definitely we could find these number of pairs if we choose this as our answer, and we will in the end we can return that. Now let's have basically our while loop, which is basically checking left and right pointers so that they don't cross each other. Once they cross, they'll come out because they have processed all this range that we have just created. So what range in the first example, what I was talking about is this range. Range in the first example would be this 0, 1, 2, 3 and da 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 till 9. Okay, so this range I'm talking about. This is where we are applying this is of size here is, we are saying like hypothetically we are choosing this size to be m. Okay, now let's apply some binary search here. So let's find out mid would be the way we do it, left plus right and divided by basically 2. Now let's find out num pairs from this helper functions that we are going to create. So let's call it find pair with difference. Okay, with diff, find pairs with diff. I'm just gonna call it, I'm just trying to make it more sensible. Okay, so we are sending this as maximum difference over here, and we're gonna implement it on top. So diff this, let's write it later, we'll come back to it, but before that let's finish it. So if this number of pairs is greater than or equals to p, that means this could be our answer, right? This could be our answer. So res would be minimum of res and this res and basically m that we just found this number between these rays somewhere, and if we are choosing that means we could find a better answer before in the first half of the range. Let's say if we were trying 4, just like in the conceptual part we were trying 4, we could find something else, like 1 would be the answer. So how about we move the right pointer to mid minus 1, m minus 1, else we would move our left to m plus 1s, because this m was basically too small and we couldn't find a right number of pairs which surpassed p number of pairs that we are trying to find. So we'll just increment our left pointer, and then in the end we will just return our result. Okay, I guess you can see this. I'm just gonna try to make it more compact, okay, so that you can have a look, nicer look. Let's write down our algorithm to find the number of pairs that have at least where the max difference is the difference. We're trying to find some number of pairs that have their difference lesser than m. Okay, that's like the simplest way of defining it. So we're gonna have it count, let's call it initially 0, and then we'll have like a pointer, let's call it 0, starting at 0th index, and then we will enter into a while loop while I is less than length nums. And what I'm gonna do is, like, I'm gonna go this particular thing I wanna put in the beginning so that it makes more sense that we were sorting in the beginning. Although this will, when the flow of the code is basically this goes from here, and having nums.sort here wouldn't matter because it will sort the array and then it will call this helper function on the top, and because nums is referenced, it's a reference value because arrays are referenced from this same memory location, so that will also receive sorted array because this really needs the sorted version of the array. So we go to the last second last element, not the last element, because we're trying to compare it to the next element. Okay, What I'll do is I will check if my current element, which would be nums I minus nums I plus 1, if the difference here, and that remember this has to be absolute difference, so let's put it inside this inbuilt function called ABS. If this difference is lesser than or equals to m, which is the maximum difference we are choosing right now, if that's the case, that means I want to increment my count will be incremented by 1, not just equals to 1 plus 1. Then I will increment my pointer basically by 2, because I want to skip the next element, because I'm choosing it as my current pair. And then what I'll do is, let's say if this did not pass, that means this pair I don't want to choose, I want to choose the next pair, but I want to at least give my next number a chance, this number a chance, so I'll increment the this next pointer I pointer just by 1. Okay, I think this really makes sense to me. I guess it makes sense to you as well. And then finally we can just return this count. Okay, we can just return this count, num pairs, that is the number of pairs that we found that has a difference less than or equal to m. And I guess in this scenario you have the entire code. I'm gonna zoom out so that you can have a look at all the code, and we'll run it on our test cases and see we have an issue. We do not have an issue. That is fantastic. So let's submit it, and I really hope we did not mess up. Okay, awesome. So I guess time to write down the time complexity. Time complexity would be big of n is the size of nums, because this particular thing that we are doing, it takes n n linear search. It's a linear search, so it takes a linear complexity, which is n, if we're choosing n as the size of the array. Then we have log m. M is basically the size of this range that we were trying to basically go through one by one in brute force, but now we're doing a binary search on this range, right? And space complexity, we're not using any space, are we? I don't think we are. So let's even write that down. So space complexity would be constant. That would be big of 1. All right. Voila, we are done. Let's go to AlgoYogi and mark this solved. So, and see you guys later in the next problem. Until then, bye bye.